practical calibration test. So our textbook example of calibration is we just basically want to find out how many gallons per acre our sprayer puts out on total volume, and then we can add our product or our chemistry to that volume at whatever rate the label asks us to do. So gallons per acre, there's this formula that we use as a guide. So say for instance, I've got a new sprayer from Rost. I have no idea what it puts out. So I'm gonna set the pump and set the pressure, and I'm gonna collect liquid from all the nozzles for a minute to get this GPM number. So say I collected 6 gallons, and I know that I want to travel at 3 miles an hour, and my width of my spray boom is 10 feet, so it's 120 inches. I know that this machine is putting out roughly 100 gallons per acre. Make note that if you change the pressure, it will change that rate, and you typically would want to repeat this a number of times to minimize mathematical errors. But pre-calibrated nozzles offer us another tool for easier calibration. Basically, ISO, the International Standards Organization, has standardized the nozzles based on their orifice size and color-coded them. And it doesn't matter whose company you're buying the nozzles from, these ISO color codes are universal. And it tells us how many gallons per minute that nozzle will put out at a given PSI, in this case, 40 PSI. So if we're going to do a calibration, a catch test with a calibrated nozzle, we can set our spray pressure at the nozzle at 40 PSI. We can collect, I'm a little bit short attention span, so I only collect for 30 seconds. So if there's 128 ounces in a gallon, and we've got the white nozzle on here, so we know at 40 PSI it should deliver 0.8 gallons per minute. We multiply that by 128 and divide it by 2 because I'm only collecting for 30 seconds. That tells us that I should be collecting 51.2 ounces for that nozzle. If I collect less than that, it might mean that that nozzle is plugged. If I collect more than that, it probably means that the nozzle is worn out and should be replaced. And what we want to do in this case is collect from each nozzle to compare the wear across the boom. If that wear is more than 7%, then the nozzles should be replaced. So when choosing these nozzles, one thing I want people to be aware of is that there are different wear rates. Brass nozzles were the first nozzles that were used because brass was easy to machine, but it also wears very quickly. There's a conception out there that stainless steel wears much longer than anything, and that's actually not true. Ceramic is the best material, and polyacetal is what most spray tips are made of today. Actually wears pretty well, and the economic value is very, very good. So the traditional way of choosing nozzles would be that we would find a chart like this. And one of the problems that we have is nozzle spacing. All of these charts were basically made for row crop, and very few of them were made for anything special as far as specialized crops. So we would have to choose spacing, we'd choose a speed range, and even speed ranges may not be on these charts. And we'd have to extrapolate, if I wanted to apply 15 gallons per acre, I'd have to find these numbers down here, then come over here and figure out what pressure I should be spraying, and then lastly, see if maybe I'm going to be using the right droplet size. So these charts are actually kind of a problem. And especially when we're talking about specialized crops, nozzle spacing, that's the big question. So in specialized crops, we define nozzle spacing by the width of the row divided by the number of nozzles. So if we have a 10-foot row between hop rows, for instance, these are hop plants, and if I'm going to spray the whole thing, I might be using 5 nozzles on either side. So that's a total of 10 nozzles. So in this case, that means that our nozzle spacing is 12 inches. And this is because EPA doesn't regulate products based on how high they are and how many number of nozzles. They do everything based on GPA, or gallons per acre, or gallons over ground spatial area. So for instance, if we were only going to be spraying the lower portion of a plant and we're only doing four nozzles, we would do 120 inches divided by 4. So our nozzle spacing then would be 30 inches. So keep that in mind. That helps us when we come to a tool like this. And a tool like this is a better way for us to choose spray nozzles. First of all, it's available as an app or as a web tool. This happens to be one from Hypro or Pentair. We can put in a specific nozzle spacing, which is very helpful for our high value crops. We can put in whatever speed we want to go. We can put in whatever rate we want to apply. And we can even indicate droplet size. Now the question is, where do we get the droplet size information? Well, we get it from the label. And in the precautions or the use area of a label, it's going to identify droplet size. In this case, it's saying medium or coarser droplet for this product. So that's where we get that information, and we can enter that here. In this app, I like to just leave that unfilled and then press submit. And it'll put out some information like this. First of all, it'll tell us exactly what pressure each nozzle should be sprayed with. Again, these are ISO color-coded nozzles, so they're pre-calibrated. And if you notice, the gallons per minute is the same for each of them. And that can be used as a tool for calibration as well. But also, it's going to tell us what droplet size we're going to see with that nozzle at that pressure range. And in this case, we see a medium droplet. And that's good because that's what's on our chemistry label. There are technologies out there called air induction that create larger droplets. And it also is showing us some options here. Again, the pressures are the same as the non-air inducted nozzles. In this case, and we see that the gallons per minute are the same. But in this case, we see, okay, this 025 nozzle has got a medium droplet, which is still good with our chemical label. And this droplet at 59 psi, or this nozzle at 59 psi, is developing coarse droplets. It's also on our label because it's under coarser. And we may choose that because it may minimize some of those drift potential droplets. So that's just a way for us to choose nozzles. And lastly, as far as a calibration, a practical test is really kind of what we do every time we do an application. But if you want, you can do it first with just water. We have a defined area. So if we know we have 1 acre that we're going to cover, then we define the nozzles, we set a constant speed, we set a constant pressure, and we go through that field and record the volume. So if we expected to apply 100 gallons per acre and we come back and we have 50 gallons left in the tank, then we know that we're off somehow. Either we have to change our pressure or we have to change our speed, whatever, because we under applied by 50 gallons. And the same as if we got halfway through that 1 acre and we were out of our 100 gallons, then we know that we've over applied. So every time we do an application, we kind of do this practical test, or we should be doing it, just to make sure that we're actually applying the volume that we intend to.